Okay, so we just saw the distance formula for 2 points in three-dimensional space, and now, based on that distance formula, we can ask, well, what are all of the points, let's call all of those points kind of collectively or generically in the form xyz, which are a distance of 5 units away from the point 134. Well, here's how we'd set that up, right? The distance between this generic point xyz and this specific point 134, there's the distance formula being applied on the left, that must equal 5. Now this is fine, this is an equation for the shape we're talking about. It just happens to be a little easier to deal with by squaring both sides. So you see this 25 here instead of a 5. And the shape we're actually talking about here, if you're in three-dimensional space, all the points that are exactly 5 units away from the point 134 ends up forming a sphere, right? This is a sphere of radius 5, whose center is at 134. And so just by example, we could turn this into a proof and all that, but I think the concreteness of just using specific numbers, I hope it's clear what's going on. By example, we could do another example and another example, and eventually we should recognize the pattern that a sphere with center HKL and radius R can have, here's one way to write an equation for such a sphere. This is what we would call probably a standard form of equation for that sphere. So then let's think about what region is represented by the following inequalities. So we have x squared plus y squared plus z squared. That, by the way, is a distance formula. Again, it's just, you don't see the minuses because it's always a minus 0. So it's actually the distance, x squared plus y squared plus z squared, you see in the middle of this double inequality, is it's the distance between the point xyz and the origin. It's just how far away a point is from the origin, and that has to be between 1 and 2. Sorry, it's the distance squared, right? So that's why, even though there's a 4 there on the other side of the double inequality, I'm saying the distance has to be between 1 and 2. We're talking here then about all points in three-dimensional space where the straight line distance away from the origin must be between 1 and 2. And in addition, the z-coordinate must be less than or equal to 0. So we're not allowing the z-coordinate to be positive. No z equals 0.1. Yeah, the first double inequality would allow it, but this third inequality, I guess I'd call it, z less than or equal to 0, that we're adding that restriction in. Right now, we want all of these things to be satisfied. What should this look like? I would say that this looks like hollowing out a cantaloupe, right? So if where the slicing of the cantaloupe occurred here all the way across represents the xy plane, and then below that is, the sort of the flesh or the meat or the whatever of the fruit, here is, I think this is a very good representation of the region we're talking about. Of course, I'm assuming that kind of right where my mouse is here, that would be the center of the sphere, that the beginning of where the hollowing out of the seedings is, that would be a distance of 1, and that the very edge where the kind of green rind layer of this melon is, that would be distance 2 from the origin. Okay, here's your interactive question for the day. In words, describe the set of points in three-dimensional space satisfying x equals z.